at a different time. Similar remarks hold for being under the illusion of being spatially displaced. Well, that anyway is the Cartesian materialist position, the person who, my opponent, who wants to identify the subject with the brain. I've sort of labeled these things 1 through 3 here. Rip correctly could discern the temporal features of the objective events. Rip correctly could discern the temporal relations among his mental events. That's number 2. But 3, Rip was incorrectly aligning these two sequences because he was under the illusion that he was in the year 3000 or 3006. Actually, I just realized I flipped back and forth between 3000 and 3006 on these slides. It doesn't matter. Nothing hangs on whether it's 3000, 3006. Okay. Before addressing this proposal in more detail, the Cartesian materialist proposal, let me point out that the analogy with Evans' submarine example is misleading. In Evans' example, the subject continues to have a body in the surface ship that is capable of becoming a point of view, but is temporarily using the submarine as a surrogate point of view. In Rip's case, his brain has no point of view available to it other than Rip 3K. There just isn't a fallback. I'm not going to pause to worry about this difference, though for some purposes it's a crucial difference. At this point, we have two views on where the subject is. A Cartesian impulse to identify the subject with something, and if one's a materialist, the only thing that seems suitable is the brain. And a Kantian alternative to identify the subject as a formal entity defined by the contents grasped. Cartesian says the subject is in 2006 because that's when the brain is. The Kantian says the subject is in the year 3000 because that's when the point of view is, as defined by the contents grasped. The Cartesian says that Rip is correctly assessing the temporal sequence of his subjective states, but is misaligning that sequence with objective events because of the illusion induced by his unusual situation. The Kantian says that Rip is right. Can any progress be made? That's what Project C was meant to address. When the project leader grabbed the report titled Project B, Temporal Displacement, Data-Mediated Temporal Displacement, from his desk and handed it to Rip to read, he inadvertently grabbed the wrong report. Project B, the one Rip had just read about, was never funded and never implemented. Rather, a successor Project C is the one that finally got approved and was implemented. Project B, recall, was to arrange to have Rip's brain in 2006 control a clone of Rip's body in the year 3000. Project C, about which Rip has not yet learned, was yet more ambitious. It was realized that the radio transceiver technology that allowed for the displacement of Dennett's brain from his body while maintaining the neural signals could also be used to separate the brain into parts while maintaining their neural communications. This had been successfully tested in some cases where a subject's brain was removed Dennett style, but rather than having the brain intact in one vat, each hemisphere was given its own vat. All the neural communications between all three entities, the two brain halves in the body, were maintained via the radio links. A subsequent successful experiment had another test subject's brain divided into 9 parts. Again, each was given its own vat, and the integrity of all the signals between all the brain parts in the body was maintained via radio links. The success of these experiments is what led to the proposal in Rip's case for Project C. Project C called for Rip's brain to be segmented into 9 parts, and for the parts to be spatio-temporally dispersed. Fortunately, the scientific team from the year 3000 knew about Project C and sent back not 2, but 18 hard drives, 2 for each brain part, a full drive consisting of all the inputs to that brain part, and an empty drive for recording all the outputs from that brain part. Project C called for all brain parts except the cerebellum to be frozen in 2006. The cerebellum was then given as input all the data from cerebellum input drive, right here, which is full, pre-recorded, sent back from 3000, and all the outputs from the cerebellum recorded onto cerebellum output drive, right there. When it was done, the cerebellum was preserved in formaldehyde, and everything placed in a bunker. Every 100 years, a successor scientific team would thaw another brain part, feed it its inputs and record its outputs. So, for example, in the year 2100, Rip's left occipital lobe was thawed out. It was given its inputs, and all of its outputs were recorded. You'll notice I have here 9 channels of inputs and 9 channels of outputs. Altogether, there are 10 entities. There are 9 brain parts and the body. Each entity then will get inputs from all the other 9 entities and send outputs to all the other 9 entities. Any outputs to itself won't be mediated by hard drives. So if there's connections from occipital lobe neurons to occipital lobe neurons, those are just going on within here. So the 9 channels of inputs would be 1 through 8 would be the other 8 brain parts, and then 1 from the body, and those are processed by this, and then all of the things it sends out, all of the left occipital inputs to the cerebellum, left occipital inputs to the right occipital lobe, left occipital inputs to left frontal lobe. Altogether 9 channels of outputs, and so on for each brain part. In the year 3000, the team had 9 preserved brain parts and 9 now filled hard drives right here. These are the 9 output drives. Each of these drives contained all of the output signals from its designated brain part, whether those outputs were going to another brain part or to the body. The text then took from each of these drives the subset of the signals that was designated as being sent to the body. So one of those 9 streams in each case for each brain part is the signal that that brain part was sending to the body. And those are collected together to form one motor output signal, the entire brain's output, motor output to the body. This was then fed to RIP3K as the motor command sequence. After RIP3K's death, the body's sensory signals and all of the, so this is happening here. This is RIP, motor commands controlling the body, body sensory inputs being recorded on the hard drive as before. After RIP3K's death, the body's sensory signals and all 9 of the brain area output drives were similarly processed to yield the 9 brain area input streams that would be sent back in time. So you take each of the 9 hard drives. So suppose this is the cerebellum, signals to the cerebellum. You have 8 drives from the other 8 brain parts, and you take their signal, that stream of it that was designated as to the cerebellum, and the body's sensory signals that were designated as to the cerebellum. You combine those 9 channels to the everything to this, that becomes the cerebellum input channel. And then this is one of the hard drives that gets sent back in time, the one that's full, the cerebellum input's full drive. The details of how this worked were in an appendix to Project C. I won't bother reading that now, but trust me, it actually all works out. The short version is that the information processing that Rip's brain did was completely intact, but different aspects of that processing were done very different times over the intervening 1,000 years. The cerebellum did its processing in 2006, the left occipital lobe in 2100, the left frontal lobe in 2900, and so forth. Now, a little bit more about temporal ascription. So what are we to make now of the temporal self-ascription that occurred when Rip saw the flashing light and heard the bark? The Kantian account, recall, is that Rip's ascriptions are correct. Rip, the subject, saw the blue light, and then the red light, and then heard the bark. This is true because this is what is specified by the indexical contents Rip grasped. And it is true even though the auditory cortices did the information processing that constituted the registration of the bark 300 years before either occipital lobe processed any information from the flashing lights, let's say.